What is up, good people of YouTube? Welcome back to my fifth video now. On today's video, we're going to be talking about RCC, or the Reset and Clock Controller, which essentially allows us to change the system clock to different frequencies. It allows us to run our program at faster rates if we wanted to. So essentially the end goal of this video is we can get our system clock from the high-speed internal of 16 megahertz to using our external oscillator. And if you take a look at my board, it embeds an 8 megahertz external crystal oscillator, and we're basically going to be getting that 8 megahertz oscillator all the way up to the maximum clock rate of 216 megahertz. Now, if you want to do this a little bit of a simpler way, you can definitely go with the CubeMX configurator, which essentially allows you to do everything right here. You put in 216 megahertz, and it spits it all out, and it's going to look something like this, where you get your system clock config, and it has all these little functions. And if you do with the low-level driver, essentially you're going to get the same thing back and forth. But of course, on this channel, we kind of want to go through everything and all the steps that happens to get from here to here, actually looking at the registers. So we're going to go through that today. I will say that I wrote this function about a year ago, and when I was just kind of reading over it to kind of get an idea of what I was doing back then, so I can talk about in the video, and then I was kind of cross-checking it with the reference manual, and I was seeing that there's a lot of things that actually don't really match it with the reference manual. So if you look at the reference manual, there's going to be a few things that it says to do, a few registers that it asks you to set, things to wait for. And this function doesn't do all of those things, but it works. So this might be a little bit of a press the I believe button, and I think this was just a fact of trial and error at the time, and it kind of came out to this result. The other reason is that the CubeMX generator, this function right here, which does the exact same thing, also doesn't follow the reference manual to a T. And I think that when I was writing this function, I was kind of going more off of the CubeMX function rather than what the reference manual was saying. So we're going to talk about both. We're going to talk about the reference manual, talk about the CubeMX, and we're going to kind of see what is necessary and what can be added if you kind of want to go by the book. So the first thing that we have to do is we have to enable the clock to the power section of the microcontroller. We're going to do that on that first line right here. Next is we have to turn on voltage scaling down to scale 1. And the reason for that is from the reference manual, we can see that in order to go into overdrive mode, it has to be in either scale 1 or scale 2. In this case, we're going to choose scale 1. The reason for that is just because QMX does that there. So we can kind of just go off of that. Next is we have to enable overdrive, and that is going to come in this line. And so the way that the reference manual goes through the entering overdrive procedure is there's a few steps to it. Basically, it asks that you configure the RCC first, and then you set the ODN bit in the power 1 control register, and then you have to switch overdrive, wait for that overdrive flag to be set, and then you can kind of do all the other fun stuff. For some reason, though, you don't need to actually do the overdrive switch bit, and you don't have to do all this kind of waiting stuff. You can kind of just go straight for it right here, set it, and then set and forget it, and move on from there. So we're going to kind of move on from the overdrive. And the other thing that's a little bit interesting about all this stuff is that if you go into the RCC section of the reference manual, nowhere in this entire section, unless maybe I'm missing like a one line somewhere, but nowhere in here you can actually find that you have to do this overdrive enable stuff. And then the next thing that we're going to get into is this wait state stuff. It doesn't actually tell you that you have to do this. So this is all from also looking at the CubeMX configuration, as well as doing some Googling online. So next thing we have to do is we have to enable clock access to the system configuration peripheral. And then what we have to do is set these wait states. So we're going to go over here, and I'm going to show you where that exists in the code. So if we go to flash on the side, and if we go down to, just going to scroll to it all. Here we go. Okay, so wait states according to CPU clock frequency. So if we're running our microcontroller between 2.7 and 3.6 volts, which most of us are probably going to be doing, running at 3.3 volts, then in order to get our clock frequency between 210 megahertz and 216 megahertz, then we have to enable 7 wait states. So that is going to be the number that we have to remember, is 7 wait states, or 8 CPU cycles, in order to read and write from the flash. And that is going to be the next thing that we have to enable. So it also talks about here increasing the clock frequency. So we have to set a new number of wait states in the flash ACR register, wait for those to be set, and then we can go about doing all the other configurations. So what that's going to look like here. So first we enable the clock, as I talked about, set the ACR register to 7 wait states, and this is just, if we go to that register, and I apologize, for some reason my .h file is in Visual Studio Code. I opened it up today and all my .h files are formatted super weirdly. If anyone has any idea how to fix this, I've been Googling all over, can't find anything, but my .h files just look absolutely ridiculous right now. But here it is in the STM32 F722.h file, 7 wait states set to 0x7, and then program that right there. And then if we go down to flash and then flash registers, we can see the flash ACR register, and then right here is latency, and if we set it to 0x7, it'll be 7 wait states. Easy as that right there, and then we wait for that to actually be enabled. Moving on, so next we have to turn on the high-speed external oscillator. So we turn that on and then wait for it to be ready. Sorry, this comment is not correct. So originally I was working with the internal oscillator, but the external oscillator is much more accurate. And if you want to do stuff like adding a USB functionality, communicating over the full-speed USB port, you're going to have your own basically accurate external oscillator. The internal oscillator isn't accurate enough for USB communication. So next part of the PLL configuration, so the PLL is a phase locked loop, and the PLL essentially allows us to scale the input frequency up and down to achieve the frequency that we want to. So what we have coming in is 8 megahertz, and what we want at the other end is 216 megahertz. And what happens is it goes through a bunch of different phases, a bunch of different kind of steps, and I think the easiest way is just to look at the clock tree over here. So it starts at 8 megahertz, and in order to get into the first PLL section, the frequency actually has to be between, I think it's like between 2 megahertz and it might be like 8 megahertz. So first we have to do is we have to scale the frequency down, 8 divided by 4 to 2 megahertz, and then we scale it back up by multiplying by 216 to get to 532 megahertz. Then we scale it down again, back to 216, and then we have to choose our system clock as this peripheral, as this PLL clock over here. So you can either have your system clock running off of the high-speed internal, directly from the high-speed external, or this PLL configuration over here. So in order to get up to 216 megahertz, we're going to have to go from over here, and that's going to allow us to configure this like that. And then everything else kind of falls into place. And we'll look at the registers right now to see exactly how that's done. So the first thing that we're going to have to do is we're going to have to disable the PLL, so that's bit 24, turn the PLL off, and then now we have to set the PLL clock source to come from the high-speed external oscillator. So this is all going to be in the PLL configure register, and if we go over here, we can see the RCC PLL configure register down here, and over here PLL source. So you can either choose the high-speed internal or the high-speed external as the PLL clock. So we're going to choose high-speed external and then configure. So there's 3 different numbers. There's M, N, and P. So each section, the M part, the N part, and the P part have to have a different scaling of frequencies. So if we go to our first stage, which is the M stage, we see that it has to be set between 1 megahertz and 2 megahertz, and it recommends 2 megahertz. So we're going to start by clearing this register, and then we're going to set it to 4. So 4 is basically going to divide 8 by 4 down to 2, and that's our first part. Next is the end stage, and the end stage is up here, and the frequency for the end stage has to be between 100 megahertz and 432 megahertz. And to get to there, we're going to multiply 2 by 216 to get up to 532. And 532 is going to go in here, be the output of here, but what we actually write to this register is 216 pushed over 6 times, since this is 6 bits over. Lastly is the PLLP register, and you see here the software has to set these not to exceed 216, and since 216 is our maximum what we're trying to set it to, we basically want to get back to 216, so we clear this bit to 0, so it divides it by 2, so we go from 532 divided by 432, don't ask me to do math on the fly, 432 divided by 2 brings us down to 216, which is going to be our output for the phase lock loop. And then now we're going to turn it on and wait for it to be ready, and that is going to be our configuration over there. Now, last part is we have to actually make sure that the different buses, so there's the AHBs and the APBs. The APB are the advanced performance bus, and then the AHBs are advanced high performance buses, are set to the right frequencies. And if we look again at the CubeMX, you can see that each bus has a different max clock speed. So the APB1 bus has a max clock speed of 54 megahertz, APB2 108 megahertz, and then I believe AHB clocks can run off of the 216 straight megahertz, just like that. If you go over to the first AHB, this is just straight 216 megahertz divided by 1, so basically no division. Next is for APB1, we have to get down to 54 megahertz, so we divide by 4. To get to APB2, which has to be 108 megahertz, we divide by 2. And then now we set the system clock as the PLL, so we switch it from the high-speed internal over to the PLL, wait for that to be switched, and now we're all done. And we basically set this variable system core clock to 216 megahertz, so that in case we need to access this anywhere, access this variable, we know that it's set to the right value. So this essentially is the flow of going top to bottom, setting from your input all the way to the output. And if you want to do it the easy way, and honestly I would probably recommend doing it the easy way, which would be going through the CubeMX, because the whole purpose of bare metal is to really see what's happening and to run your stuff faster. But for initialization functions, it's usually best practice to just kind of follow what the manufacturer recommends. And in terms of clock and whatnot, I don't think there's really harm or foul in going with what the manufacturer recommends and what their code is. But in this case, if you want to do it all on your own and kind of walk through all the code, you can see it all is right here, and we can step through it line by line like this, which is pretty nice. So that's going to be all for this video. Thanks for sticking with me. In the next video, we're probably going to go into Flash and the EEPROM, which allows us to store memory even when the microcontroller is turned off. So stick around for that video. Looking forward to seeing you there.